let's go to solid-state batteries and materials innovation. And for this, we are very fortunate to have Dennis with us, CEO of Polestar, as well as Doron, CEO of StoreDot, as well as Srinath, Global Head of Automotive Research at Oliver Wyman, and Pooja, PhD researcher at the University College London. And if we can bring them all up, here we go. Amazing. People coming on there. Fantastic. Maybe missing one more, but that's fine. We'll get to this in a second. Maybe just if you can put in the chat if there's someone still coming now, if you're maybe just waiting, that would be brilliant. And maybe just one thing before we really start the kickoff the session, because we have done this earlier as well. We love to keep this somewhat interactive. So, please put any questions you might have in the comments anytime, and we will try to address them during the session. So please don't hesitate to ask any questions you might have. And I think to kind of kick us off, because especially on the topic of solid state, it's something we also as Battery Associates just spent quite a bit of time on. With we, I mean mainly Pooja, Srinath, and Mariano, who worked on an incredible white paper, which has been quite popular over the last few weeks. So I think we launched it a week ago, actually, a few hundred downloads pretty much immediately. So we can tell this is a very highly demanded topic. And so I think we thought about maybe just Srinath, if you want to kind of kick us off a bit in the beginning, just to kind of give us a bit of an overview kind of what solid state means and why we care about this topic. And then we will go to every other panelist as well.
Absolutely, it would be my pleasure, Simon. Let me just start by quickly sharing my screen. Like Simon said, we have published a white paper on solid state batteries from Battery Associates couple of days back. We tried to coincide this with, on one hand, the IAA Motor Show in Munich, but also on the other hand, with an eye on our own battery day today. And what we did in the weeks building up to where we're writing this white paper was to basically do a status quo analysis on what's the current state of affairs in the solid state battery sector, what's happening from a technology side, from product technology as well as production technology side, and then also to chart out the way forward and what's going to be happening, or where are the interesting things happening and where the industry or where the sector seems to be moving. To provide a brief overview on that, or probably one step before that, why we are so interested in talking about this when you're talking about solid state towards the future, and just to put some numbers on it. So in terms of market size, and these are all estimates by reputed institutes and reputed organizations. So in terms of market size, about $8 billion in roughly 10 years from now, but kicking off sometime after 2025. So that's 8 billion within 6 or 7 years in terms of growth. Bloomberg Finance estimates that it could be up to 317 gigawatt hour by 2035 of demand for solid state batteries from passenger vehicle sector, penetration of 7% in terms of consumer electronics market, says Faraday, and they also expect at least 4% by 2030 in terms of passenger cars. So if that's the size of the market and the kind of penetrations we are looking at, what are we really talking about? I think it's also probably a good idea to have Pooja join me when I talk about this slide, because she's really the technical expert on the topic. While you're waiting for her to join, of course, I can already say that, there are, of course, different types of solid electrolytes. There is polymers and organic types. On the other hand, we have the inorganic types, where primarily sulfides and oxides are the types of solid electrolytes which are being heavily investigated right now, each with their own pros and cons. Pooja, take it away. It's probably best when you talk about this.
Yeah, no, you give a great intro. But yeah, I think typically for solid electrolytes, we kind of think of the inorganics, and this is mainly because they have higher ionic conductivity compared to polymer. And the two kind of main categories are the sulfide solid electrolytes, which are kind of softer, they're mechanically very soft. So that means they can be incorporated into the cathode materials quite well and kind of cold pressed together. So that's very nice for like manufacturing and processability. They have very high ionic conductivity, so that's very good for charging. The lithium transport throughout the solid electrolyte is very fast. The main issue with sulfides is basically its electrochemical stability against the lithium anode, and this is mainly, the electrochemical window. When you're cycling a cell from 0 to 4 volts, or when you use high voltage cathodes up to 5 volts, there is degradation there with the lithium metal. And the sulfides kind of reduced and form resistive compounds at that interface. And that's kind of one of the main limiting performance areas for sulfides. The other issue as well is the dendrite formation, which is the buildup of lithium metal. And we kind of think that maybe harder materials with a higher Young's modulus would be better to mechanically prevent these dendrites. So this is kind of some limiting areas of sulfides. And, you know, they also, when you put them in a dry room, when they react with moisture in the atmosphere, they kind of produce some toxic gas, H2S gas. So you have to be very careful about how you're going to process them. The oxides, kind of on the other hand, don't have this sensitivity with reacting with moisture, so that's very nice. And they have a high electrochemical stability window with lithium metal. The kind of opposite side for oxides is basically how do you incorporate it into cathode materials, because it is they have such a high Young's modulus, you can't just mix them with cathode material. They also require sintering at very high temperatures. So if you mix it with the cathode material and use high temperature to kind of press the materials together, you'll get a decomposition product. So usually you use like some kind of wettability or coating layer at the oxide and cathode interface. But this is, again, then, you know, a lot of manufacturing steps. So I think with both technologies, there isn't a clear winner, and kind of using things like coating layers for the sulfide with the lithium side, or on the oxide using a catholyte layer, is kind of some of the strategies that we think that would help commercialize solid state batteries.
Yeah, and I think the main takeaway from that is, of course, that both are technologies which are still under development, and there are, of course, a lot of pros and cons for each of them. And this is actually also reflected when we think about the kind of process steps which are necessary in manufacturing a lithium metal sulfide or lithium metal oxide solid state battery. In some cases, it's not just a dry room requirement, but also inert gas argon a requirement in a glove box, for example, if you're talking about sulfides especially. On the other hand, the promise is that using solid electrolytes gives the potential of doing away with many process steps in between, which again has a knock-on effect in terms of reducing costs and improving the profitability of companies which are, you know, selling such such products. So Pooja, do you have some comments on the manufacturing side?
Yes, I think, like you said, with a solid state battery, you know, you have the advantage that you don't have a flammable liquid electrolyte. So when you're kind of doing gassing and things like testing of the full cell, you don't have to put those steps. But of course, you have a solid electrolyte, so there's additional manufacturing steps to that to consider. So one thing a lot of industry and academia is kind of looking at is trying to develop this anode-free cell. So basically, you wouldn't have to deal with lithium metal foil, which is very reactive and hard to kind of process. You would basically just electrochemically plating the lithium from the cathode material, and then plating this onto the current collector and forming the lithium metal in situ. And this would, again, reduce a lot of the manufacturing cost and stages.
So where do we go from here? If you think about it, there are still a lot of challenges also on the product side. On the left, what you see in terms of you know, specifications and targets which need to be reached to make solid state batteries ready for commercialization in terms of solid electrolyte thickness, or in terms of deciding what kind of formats they are going to be available in. Is it even possible to do it in a prismatic or a cylindrical format, or is it going to be pouch cells, which are the most preferred and you know, from a physical and chemical point of view, the most suitable format to package them in? The operating temperatures and pressures, of course, are also important to keep an eye on in terms of improvements and in terms of improving technology maturity. But even if we manage to complete all of these activities in terms of product technology, I think there was a quote from one of the industry executives a few months back, where he said that, hey, we think that we're 90% there with solid state batteries, but you know, the remaining 10% is the most difficult part. And if you think about it, if we say 90% is just developing the product, what is this remaining 10%? It's actually where a lot of devils are, you know, hiding in the details. Is it, if you think in terms of synergizing with existing plants, in terms of investments that are going in, how do you spread the capex and equipment costs? Can you transfer some of them into solid state battery manufacturing as well? What are the use cases where you're going to find applicability of solid state batteries? Is it competing with LFP and NCM liquid electrolyte-based batteries that you're having today, which are going to be much more entrenched in the next 10 years? Or is there going to be specific applications where they do find much better suitability in terms of cost, in terms of performance, in terms of quality, and so on? On the other hand, even if you have all these innovations on the product, process, and production side, there is still the need to grow entire value chains and supply chains to cater to the sector. And this requires the participation of a wide range of players, both upstream, downstream, recycling, design, data analytics, and so on and so forth. And the last but not the least, the most important thing is also to make sure that right from the design stage and the product development stage, factors like sustainability and circularity are built in into how these products are made and commercialized. And I think those are all very interesting topics on which we can discuss with our other panelists. So if guys, you want to come back in, then I think this would be great.
Simon, sorry.
Rookie mistake. Finally, I did it once as well. It always has to happen at least once in a conference like that. Okay, no, thanks again so much, Pooja and Srinath, providing a nice introduction on this work and kind of summarizing a bit of the landscape and the need for kind of innovation, not just in solid state, but also beyond materials innovation more generally. And I think, yeah, as you just said, we have two fantastic other panelists with us today. We have Dennis from Polestar as well as from Doron from StoreDot. So yeah, so I think now would be a good time, because what's quite nice about this panel, I think, is that we have people from from academia, people from a startup commercializing, and then a bit of a bigger company. As you said, I think earlier, in between a startup and a big OEM, like a bigger traditional company. So it's quite big compared to maybe some smaller companies. And maybe could we just start maybe with Doron, with you, and maybe if you can just share. I know you've been working on the battery material space for quite a while. Maybe just a bit on your perspective on where this is going, why you maybe also looking now into solid state topics as well, maybe also some of the updates with the really fast, high rate, larger cell formats as well.
Yeah, so definitely solid state is a great promise, and it will happen. I think there's over optimism in the marketplace as to the potential timeline for introduction and commercialization of the technology. I mean, what we have seen with the extreme fast charge technology that we've been working on for the last 8 years or so, that it does take 3-4 years from when you have the final configuration and the design of the battery in our labs, and as you scale it up in a traditional battery manufacturing line, such as our joint venture in China with Eve Energy. And we've seen that it does take a lot of time, not only to stabilize new materials and the supply chain, but also to make sure that there is enough know-how in order to reach some stable yield and cost for the batteries. So I think, even if we are 90% there, and let's assume this is the case, by the way, I do not think so, but let's say it is 90%, this 10% may take 5 years. And the reason is that we are talking about processes that do not exist yet in scale-up. We are talking about manufacturing facilities that do not exist. And if you go to the chart that we saw earlier about the new steps, that some of them need to be in a dry room for the electrode preparation, some of them need to have new stacking capabilities for the thin layers that are maybe more sustainable for crashing and cracking. So I think overall there is optimism, and this is why the strategy that StoreDot have taken is that it's like a two-step introduction of new technologies to the market, where the first introduction in the, let's say, next 3-4 years is to leverage more on the existing lithium-ion capabilities with extreme fast charge, meaning replacing graphite with silicon. This is like the major effort that the entire industry has been working on. Some are adding few percentage, like let's say Tesla is adding 5%. Some others are adding 20%. We are looking at 50 to 70%. But the idea is to keep improving on the existing lithium-ion capabilities with the existing traditional manufacturing lines. And then only in 2028, we can start introducing the great innovation around solid-state batteries and materials that I believe first will be more like a hybrid solid that would have some non-solid elements in the electrolyte that would enable the transfer of ions from the solid electrolyte to the active material. Because each of these interfaces, and you have 4 of these solid-to-solid interfaces in a full solid-state battery, each of those is a major challenge in terms of the materials, and some people trying to solve it with very high pressure that is not practical within the pack. And we can maybe hear from Dennis later on about the challenges of taking such technology into an existing design of a pack. And then there's also those that are looking into trying to fast charge these materials that are having high resistance as it is, and without really innovating more around the new materials, then we will have real problems to fast charge the solid state. So even if potentially we can have a battery that is, let's say, 450 watt-hour per kilogram, but if it charges in 10 hours, then again, we did not solve the problem of range anxiety, which is what is the #1 barrier for adoption of electric vehicles. So I think the strategy that we have taken, that's the first squeezing more the lemon, which is a great lemon, by the way, of the lithium-ion technology with, the Nobel Prize of Goodenough et al. From 2019. They got this prize for a reason, the Nobel Prize, because this is really a great technology. Only fast charging was not one of their design parameters as they designed the whole concept of storing energy of the lithium ions inside graphite. So replacing the graphite with silicon over time does have a potential to really keep improving on the existing lithium-ion technology before the industry transitions to solid state.
Fantastic. Thank you so much, Doron, for sharing. Yeah, as you already mentioned, now to Dennis, and maybe also talking how you can actually take something like this into a real application.
Yeah. So hi, everyone. So I'm Dennis. I'm from Polestar, small, medium-sized northern EV startup, spun off from Volvo Cars. So I will probably take the OEM perspective and talk from an automotive side. So what we see right now in the battery landscape is startups like Doron, super technically skilled, and then you have the legacy players like the LG and CATL, etc. And then you have the medium-sized startups like Northvolt and so on. And you also have this discussion then when it comes to solid state. You have some startups going for the revolution, some doing a more stepwise approach that Doron just advocated. And how are we to judge that from an OEM perspective? What should we bet on? What is the bet to get into solid state? Because ultimately what we are after, that is range, fast charging speed at a competitive price and cost. That is what we are looking into. And what can we do? Where is the S curve? Should we continue to squeeze the lemon, as Doron said? Or is there someone that actually can bring this revolutionary technology fast to the market? That is what we look into. But we not only look into the different battery cells as such and understand what chemistry that holds. We're also trying to get it into vehicle architecture. And of course, here we're going much more into cell to body in the next generations to come. And understanding that the battery cell is an integral part of the vehicle architecture. And we also need to, of course, to monitor it and steer it in a proper fashion to get the maximum out of it and to securely monitor and steer the heat and the cooling, etc., from those battery cells. So that's what we are doing right now, and we have no real responses to that or response. What we're doing is more of a multitude. We're working with many different partners. So we're working with LG, working with CATL, we're working with Northvolt. We're looking into startups. We're in discussion with StoreDot and see what they can bring. So that is the strategic dilemma that we have right now as we speak. And maybe I'll pause there for a second.
Thank you very much, Dennis and Doron, for sharing as well. And maybe also for you, Pooja, coming more from like an academic, like research side, maybe as some of the avenues you see and some of the challenges maybe to kind of like bring this innovation also into place?
Yeah, I think it's really interesting to kind of hear from the industry side. I think from the academic side, we're looking at the solid electrolyte and these interfaces, and yeah, that is one of the main limiting kind of cases. How do we make these interfaces align better and kind of cycle the cell at appreciable current densities that would be applicable for fast charging for electric vehicles? Some companies kind of have announced that they are able to do this, and if you do think about that, even if they are able to make a cell, kind of a few layer cell, and then build it up into a pack, that in itself, manufacturing process will take some time. Adding in, like if you have a sulfide solid electrolyte, you'll have to add in like a dry room or a glove box type environment that will add additional steps. For the oxide materials which don't have this, in our white paper we mentioned using aerosol deposition. The kind of speed of manufacturing of that is at least 2 orders of magnitude lower than what would be applicable in industry. So working out the kind of best technology and solving the issues of fast charging and lithium dendrites is the first goal, and then the second goal is able to manufacture these at scale for electric vehicle purposes. So there are technical challenges, and yeah, companies have announced mid-2025 decade or early 2030s. So I think solid-state batteries will take off, and they will be the future, but it's just to come to see whether this will happen in 2025 or 2030.
Thank you, Sharon. And maybe also just one quick thing before we do maybe then open round as well for you, Srinath, because I know you're looking with your work at many different stakeholders, and I know you have to try to answer many questions about the sector, because everyone wants to understand, right, where is this moving? Maybe if you want to share with also your perspective on this, and maybe from your demand side.
Yeah, definitely. Why not? I think I would just try and tee off on what Doron said earlier, and also some of the points that Pooja and Dennis mentioned when they were sharing their views. I think absolutely the first point that I really liked from Doron was the fact that this is a very, very good lemon. It's a very, very good technology that we have in place today. And even the amount of innovations, incremental, so as well as non-incremental innovations that can be done with conventional batteries have not yet been fully explored. So there is a lot that can happen, and there are some low-hanging fruits which are being explored and which are much closer to commercialization than compared with the end vision or the goal of a fully solid-state battery without anodes and so on and so forth. But it's good to have that end goal in mind, that we can have a future like that. But maybe sometime in 2050 we have 100% solid state electrolyte. No one knows, it's too far away. But if you have to be more practical, and that's the point which is extremely important when I think about the OEMs that I speak to, or suppliers, or battery makers, or financial investors who are trying to understand where should they put their money, which startups are talking vaporware, which startups have actually come up with breakthrough innovations which are worthy of putting money into or partnering with from an OEM perspective or a battery maker perspective. I think the most important thing is to accept or to be aware that in the midterm, short term, let's say, is quite clear. It's going to be the conventional lithium-ion batteries that we have now. Long term can be anyone's game. It's too far away. But in the midterm is where it's interesting, because that's when you have a mix of many different technologies still available in the market, each with their own pros and cons. So I think the most likely scenario in that case is going to be that it's going to be determined very much on use cases. So if you're talking about maybe commercial vehicles, then LFP batteries will be most sensible on milk run kind of routes. If you're talking about fast charging requirements and performance specifications on a sports car or a premium luxury car, then you're probably going to be thinking about a much more advanced battery, probably already a solid state battery, given that the cost will also be higher at the beginning, and it'll take some time for the technology to stabilize and for the cost to come down to a comparative level, or even to beat the level that high scale manufacturing facility for lithium-ion batteries is going to be reaching on a pack level. And all of this together will determine which region or which market, which customer segment, which use case is going to be catered to with what kind of battery. And solid state batteries, I think, will definitely be a part of the mix sooner rather than later.
Yeah, Simon, if I can emphasize more about the challenges with solid state, because we are looking at the deep dive into the actual technology, and people don't realize that every transfer of these ions from a solid to solid interface, and there are 4 of these interfaces, because you have the active material, let's say the lithium ion, and then you have the anode solid electrolyte, and then you have the transfer into the separator, and then from the separator to the solid electrolyte of the cathode, and then the active material of the cathode, whatever it will be. So each of these transfer of ions is a major challenge. And the only way that I see that this can be solved, at least in the coming decade, is through some hybrid approach that would enable a non-solid electrolyte, maybe a gel, maybe some polymer that has elements that enable this lower resistance movement of the ions. Because otherwise, there are so many challenges that even those that, like Pooja said, that are showing some layers in the lab, the gap from this to a full battery in a vehicle that has, let's say, $80 per kilowatt hour cost in a consistent manufacturing flow, we are looking at maybe 10 to 15 years. And I think the realization of this in the marketplace is really key, because there's so much hype. And we're talking about companies that are worth $15-20 billion for showing a product in the lab. That I think it really needs a very close look at what is realistic and not realistic in terms of introduction of solid state.
Yeah, I think that's an important point. But I think as well to kind of consider for solid state batteries is, yes, the energy density and volumetric density gains, but also safety issue. And I think this is especially important for maybe aerospace, as well as like luxury performance EVs, where maybe the cost, they can afford to pay a higher capital cost, but you don't have a flammable liquid electrolyte in a solid state battery. And that can be very crucial for certain applications. And it could make sense in those areas.
Thank you. And I think maybe also something connected to this also be looking at the questions, because I love to kind of incorporate some of them already. For example, from Sean here, are there any synergies when OEMs are looking at current market technologies leads versus planning for the future tech related to designing a car? So how would you do that as an OEM, right? How do you have your bets on these different technologies?
Really good question. I mean, what we are trying to do is to have this, because it's such a dynamic market right now, with such many dynamics in the battery cell development. So what we're trying to do is to talk to many players, understand how that works, but we're also at the same time locking in the vehicle architecture for the 25-27 timeframe. So we need also to place our bets and understand where could actually move in that area and get the technology that we need to the end consumers. So it's really tricky to do, but the way we approach it is talking to many potential partners. Collaborating is, I think, the way to scale here. And also not necessarily going with one technology, but maybe having a couple of different options for the same vehicle or platform. I think that is the way that we are approaching it today. But a high uncertainty, and also, trying to be on the competitive edge, always being a bit nervous and trying to scatter and see what kind of areas that is out there. And also trying to understand, to Doron's point then, so when you can actually show something in the lab, what is the time horizon from that one until you have it scalable and industrially in the right way?
Great point, Sarah. Thank you for sharing this. And I think that's maybe also a question, I'm not sure if you can elaborate on this, but on exactly how can you scale up these technologies and what could be a good roadmap look like, right? Because I think you said, you have the lemon, you want to kind of, have your long-hanging fruits, and what are like the steps how you can really build something which is, kind of grows and it's like, developing further over time.
All right. So what we are thinking about is you use the conventional batteries right now, and then you look into solid state, and they add that as a certain mix in the entire car offer. So it's not the volume that you go for immediately, but you go for a certain premium. And then, of course, you're after the attributes that you could communicate with the market and and take a premium price for that kind of offer. So be that fast charging or something similar that is really tangible for the end consumer.
Thank you. And I think there's also an interesting question we have actually here from the channel, which might be a bit connected also to an earlier panel we had, which was on battery data. So I can assume we have some battery data fans in here as well. But it's true, right? I think so the question is, I imagine there's a lot of experimental data being produced in the research process. Are there any plans to make use of these results and add big data analysis and machine learning approaches to the development process on the industry side? Maybe this is for the researchers in the room, like Doron and Pooja.
So actually, yeah, we do have, I would say, some terabytes of very interesting data from the cyclers. By the way, both the cyclers here in Israel as well as those that are from the production line in China, it's all being uploaded to the cloud. And every second, actually, we have a whole data set of, the voltage, the current, the temperature, the swelling. So it's a lot of data that is really fascinating. The problem is we are trying to implement machine learning and AI tools on this data, because there's no human can actually interpret what we see in terms of the correlation between, let's say, a formation procedure and the cycle life of the battery. This is something that only machine learning can teach you. The problem that I see is that during the development, very few parameters are held constant. Because we keep experimenting, and there's like kind of a random search for the best combination of materials. And therefore, if we open it to the public, and I am, all in favor, as long as it doesn't hurt our business, but I just don't see how people who are not intimately involved in the actual composition of the materials can actually learn much from this data that is really fascinating. But it is a challenge to combine these databases from various companies.
Yeah, that's a great point. I think from like the academic side or in labs, even if we're making these solid electrolytes and we're making these solid state batteries, there's no, commercial bulk solid state battery that you can do, electrochemical, characterization like you can do for lithium ion. So standardization between different research groups is very important. I think during lockdown, we wrote a review paper basically on impedance spectroscopy and trying to create a standard for different solid electrolyte materials and interpreting the data for these, which I think was very vital and very informative. But other procedures isn't standardized. So even if we make it publicly available, it is difficult to kind of analyze, compare from different research groups. So I think that's something that should be considered. A lot of times when they cycle the cells, it's done under some kind of pressure or temperature. And sometimes this pressure jig or the temperature isn't fully reported. And I think, again, standardization of that is important.
Thank you. And I think maybe also there's, I don't know if Dennis, did you have a point on this one?
No, I'm fine with that. I understand the need for standardization and access to data, and also then apply machine learning to, I think that's the only tool you have for that massive amount of data.
Brilliant. There's, I think, two questions. One, maybe on supply chain sustainability of solid-state batteries. Maybe also, Srinath, that's something you would like to address. But also we have another one on when do you think solid-state will be introduced to passenger cars? If you have any magic balls somewhere out there.
I think I'll let Dennis or Doron talk about when we can possibly see solid-state batteries being launched in the market. I do have some numbers that I've seen from different industry players, but I don't want to comment on that. Like you said, I think it's a bit of crystal ball gazing at this point of time. I think I mentioned sustainability a little earlier, and supply chains as well. So it's actually something we also heard about in the panels earlier in the day, right? So how important it is to have a circular design and kind of ensuring local production for local markets and things like this. I think that's a very interesting aspect. These are topics which we are still trying to address, even with conventional lithium-ion batteries right now, where there are, the wave of gigafactories in Europe, mushrooming right now in the next years, and pretty much something similar looks likely to happen in the US as well, to cater to the local markets. And the question really is how much of that could on one hand be converted or repurposed or refurnished to cater to solid-state batteries in the future. On the other hand, it's also a question of synergies in terms of chemistries, in terms of materials, and so on. So, what kind of materials are you sourcing today, and which of those will still be required going forward? And that is pretty much dependent on what chemistry and what kind of battery you're talking about. If you take Doron's recommendation, or the approach that Doron was talking about, that you take a stepwise approach, and one step at a time, you take out one component at a time and just move step by step towards a solid state, a pure, fully solid state solution. Then of course you also have a transition period where you have to then think about supply chains and how you keep them intact, how you ramp up and ramp down the materials that you need depending on how your chemistry mix is changing. And all of this, of course, in deep collaboration with your OEM customers.
Fantastic. Doron, Dennis, do you feel brave?
Yeah, no, so I can definitely comment on the timeline. This is more like the second question, because supply chain is a major challenge, and this is part of the timeline problem. What we've seen with the extreme fast charge technology, which is basically nanotechnology of silicon coated with some organic compounds that are proprietary synthesized, this was a 36 months effort. And this was for an existing facility. I mean, we have used the production line. I would say 80 to 90% is the same. Maybe some changes in the front end of the speed of the mixers, or the thickness of the coating that was more accurate, or more towards the 10 micron instead of the 50 micron of the anode. So there were changes in the coating heads or in the mixers, but it is the same line. Now, as we are looking at a new line with new processes, like we've seen this chart, and I think it's a very important chart that shows the new flow for solid-state batteries. I would say a conservative approach will be double that. So we're looking at 72 months for an introduction of a new process with new materials into mass production. And this is why best case, we are looking at 2028 with a mass production of a solid-state battery. And so I think realistically, and this is also in our roadmap, 2028 is when I promised Dennis that he will get a solid-state battery for me.
Thank you. And we look forward to that. That would be fantastic. Now, but maybe I could add another challenge then, because you mentioned sustainability, and that is a topic that is very dear to our hearts. So not only do you need to succeed with the 72 months from a cell when it's good, you also need to succeed on all the 3 different regions. So Asia, Europe, and US. Because what we would like to avoid is to ship batteries. It's expensive and it's not so very sustainable. So that's what we would like to also add on top of that, to be a relevant supplier and partner when it comes to the batteries in the future. So I agree on the timeline. I would be thrilled when we meet the 28 timeframe. That would be super. And we need to do that in a partnership. So then I can add one more. I believe that there is so much to learn, because it's a new battery technology, it's a new cell. You need to understand how to monitor it, and how does it charge, how do you heat and cool it. So you need to do that in parallel with the different OEMs. Put it into a vehicle prototype and architecture, and then learn along this journey together. Yeah.
Well, thank you for sharing. I think there's some of these other kind of, side effects in some way, which also could come. I mean, one thing I'm wondering, for example, from a production standpoint, right? Like if you have like different ways of production, will there be like, kind of, you said you want to create local supply, and then kind of will this be an opportunity, right, to set up these kind of new local production lines, maybe in places where they're not yet. But I guess that's something also to be seen. Maybe Doron has some ideas on this as well.
Right, and I want to go back to what I mentioned earlier about the experience of the driver. And it should be exactly like fueling, right? So we need to keep in mind, what are we trying to achieve? The fact that we can achieve 450 watt-hour per kilogram alone without the ability to fast charge it doesn't really solve the range anxiety problem. And this is why, when we look at the solution, we always look at the miles per minute at the charging station. So today we are demonstrating 20 miles per minute. And as we move to solid state, maybe we are reducing it from 6C charging rate to maybe 4C or 3C, but still we double the energy density. So we are looking at 27, 28 miles per minute as we move to solid state. And this is why we have to make it a hybrid solution, so it will be enabled to charge at 3C at least. So if it doesn't, then there's going to be a very interesting technology, but it's not suitable for electric vehicles.
I think that's a very good point. What the usability has to be figured out, and you want to create like the it has to be full package in a way, which is, I feel, in the battery world always one of the most tough things to do. It's possible to get one thing optimized, but to get all of them the way we want, it can be very challenging. Great. Anything else maybe would like to add? Maybe also Pooja, Srinath, maybe also talking a bit about some of the kind of like what could be like market drivers as well, maybe, because we spoke about maybe there's some niche applications you could come first. You spoke about like the vertical, like electric airplanes, aviation, etc. So I'm just curious, is there like any other application you have been looking at before?
Do you want to go first, Pooja?
Yeah, I think it's a good point. I think eVTOLs are very hyped at the moment. Electric vertical takeoff and landing aircraft. I think, especially for as we're trying to decarbonize and move to net zero by 2050. I think small like regional planes will be very important. And if you can kind of get that energy density, that's going to be the main point there. So if solid electrolytes can kind of have that, and the volumetric energy density is doubled compared to lithium ion, I think that will be key. I think, like Doron says, having kind of like a hybrid solid electrolyte is important. You want to basically have these interfaces kind of looked at. Some of my area of research at the moment is kind of making thin solid electrolytes or coating layers. And if we can kind of design that in a way that kind of protects, some of these interfaces and allows the lithium ions to be transferred across, it would be good. I think there are a lot of innovative and ideas that we have in industry, and I feel, in academia, and I feel if we can kind of get a bit of a collaboration with industry through academia, I think this will help the scale up of solid state batteries.
Right. And then maybe another important point that we've mentioned earlier is that, the industry keeps reducing the cost, and this is a major driver for the adoption, is that the cost of lithium-ion batteries keeps dropping. We're looking at maybe 5-7% year-on-year improvement. It's like a Moore's law of the semiconductor. We see it also in batteries. Introduction of a new technology takes a lot of time to really match up with this curve and to align with, let's say, $80 in 2024 per kilowatt hour. It takes time to really stabilize such a new technology and to reach the yield and the cost of the supply chain that is required for such a low cost. So at the end of the day, even if all the stars are aligned and some breakthrough is being achieved, there's additional time to reach the cost curve that is so critical for the electric vehicle adoption.
I think that's a very, very good point. Just to add to that, but before I comment on that, probably in terms of market, I think Dennis kind of answered this question earlier when he talked about premium segment and things like that. So basically, which markets will adopt solid state would pretty much be dependent on which use cases the products that are developed and commercialized, which kind of use cases are they able to economically address, and with what specifications, with what energy density, with what kind of quality considerations, and so on. I think that's what's going to determine in which cases they're going to be used. If it's perfect in terms of technology, but the cost is too high, like Doron says, it's a killer argument. I mean, it won't make any economic sense to pursue that, right? Probably one other point, again, thinking in terms of cost and in terms of industrialization, if you think about the current wave of gigafactories in Europe, if you go back a couple of years, the first factories which are set up were pretty much the Asian players who came to, for example, Central Europe to set up their factories for conventional lithium-ion batteries. And our discussions with them basically reconfirmed how difficult it is, even if you're having a functioning plant somewhere in Japan or Korea or China, for example, and you try to copy paste your plant, including every single parameter and just copying it one-to-one. Even then, the kind of failure rates and quality scrap rates that they had at the beginning of their operations was close to 50%. That's absolutely uneconomical, and it took them a couple of years to bring up their quality rates to the kind of output levels that they have in their parent plants in Asia, for example. And we hear this also from other players who are trying to adopt sort of a fast follower strategy by licensing technologies and setting up the medium scale battery manufacturers, as Dennis mentioned earlier. So they also have, these kind of challenges, and some of them even talk about production hell when it comes to batteries, right? It's been in the news quite a bit in terms of some players having manufacturing problems and quality issues and unable to meet the production targets set by their OEM customers. It's important that we remember that these same problems are quite likely to also repeat themselves when we switch from lithium-ion to solid-state batteries as well, right? And that's again going to play a dampening effect in terms of when the start of production and delivery of commercially and safe solid-state batteries will be on the market.
Thank you for sharing. I think that's really the learnings everyone has to take, right? And also bring it into different contexts. And I think there's quite a bit of learning for the entire industry to kind of always try to adapt, to the next technologies and also bring it to the different geolocations, because as you also mentioned, right, it's a global topic. It's really about how can we create these batteries globally and how we can really push the industry globally to be one on the scale, but also then on the the carbon reduction standpoint as well, and on the supply chain topic, which of course is a big one. Fantastic. Yeah, please, Dennis, go.
I'm just curious about how the team here looks upon the legacy battery manufacturers and their opportunity or potential to jump to this new technology. And from their perspective, I think that they need to optimize the investment either to a conventional or shift something to the new. What would be your view on that one? Is it stronger to go with the smaller startups focused on the new technology, or it's clever to go with the big ones? To challenge you a bit, what's your view on that?
So for a startup to work with a company, let's say like LG Chem or CATL, is really dangerous because they can easily swallow you and basically extract all the IP and either make it go away or bet on it big time. So I think the right strategy for the large players is actually to acquire a startup that is actually showing promising technology, and then integrate it gradually into their supply chain and facilities. And this is, I think, their approach, because they cannot really afford to cannibalize the cash cow of lithium-ion batteries, at least for the coming decade, because of the tens of billions that were already invested in the capital equipment, right?
That's a very good point. I think other dimension that should also be kept in mind when you're talking about this particular aspect is that it's sort of a moving target, right? If you think about all the battery giants today, none of them are just resting on their laurels and saying, okay, we have a technology that we have commercialized and we're happy to push out X million or X billion units of it over the next years. Of course, that makes sense from the point of view of splitting their expenditure over multiple units and diversifying that. But if you look at them, I think every single one of them has research centers, not just in Asia, but also in Silicon Valley and so on. They're actively working on patents. They're actively working on new technologies. I think every major battery maker is already somehow invested in the solid state space, either through venture investments or through own research or collaborations with universities, so that the entire spectrum of activities. So that's what makes it even more fascinating, right? You don't have the big OEMs just working with the startups. They're also collaborating with the big battery players, and the big battery players themselves are doing some in-house research as well as trying to put money into startups and university collaborations on the other hand. That makes it very nebulous and very complex, the entire landscape.
Thank you for sharing. And looking at time, we're almost at time. because we have a networking break coming. But I mean, if you have been at earlier sessions, I'd love to ask this one question at the end, because we do this once a yearly battery day. So, this question would of course be, what do you hope for? We can see over the coming year. So if we meet again in 1 year's time, what would you hope what has happened or what has been developed? So everyone is live. Pooja, do you want to kick us off? And then we go maybe Doron, Dennis, and then Srinath.
Yeah, sure. I guess from my perspective, I'm obviously working on solid state batteries, so it'd be great because there's a lot of announcements from a couple of key industry players saying that they're going to have some pilot facilities and they will start scaling up these cells for manufacturing. So even seeing a prototype in a vehicle will be very exciting. And I think, the landscape for that will be next year.
Doron?
I think, just seeing a demonstration of an experience of the driver that is exactly like fueling will be like a major step for the entire ecosystem to see that it is possible to fully charge in minutes an electric vehicle.
Dennis?
Yeah, then first of all, I would like to have a rapid acceleration of the infrastructure for charging. That's number one. But then a major breakthrough in solid state would also be nice, of course, to achieve that. And fast charging would definitely be one of the parameters that we look very closely to.
Srinath?
I think I will, of course, everything that my co-panelists have said is very desirable. I think I would put on a Battery Associates hat and say our next white paper next year on solid state batteries. That would be fun. But no, from an industry point of view, I think I would definitely also love to see, a bit more movement away from labs and demonstrators towards commercialization. And if we're able to do some of that in the next year, that would be amazing.
Fantastic. Yeah, thank you so much, all of you, for being with us for today. And I think it was an interesting discussion. I think we're going to talk about this more also later on the networking sessions. And talking about networking now, actually, there's a 10-minute break where all of you can go and mingle and meet each other. And then we're going to be back in 10 minutes with our fourth panel on training and diversity and how to get all of these people ready to help us on this battery revolution. Thank you. See you then.
Thanks a lot.
Thank you very much. Thanks. Bye-bye.